As I told you guys before, I'm actually going to be doing the linear ones today, just spending time on linear graphs. Now, as I said to you guys on, when was it the last time, or whenever I saw you last time was, like, it's, I want to make sure that you guys actually know how to find an equation of a straight line and then deal with piecewise functions as well. All right, those are those really funny looking graphs, like the step graphs that we're talking about as well. The other thing that I got some feedback on over the weekend, over a couple of days ago, was this. When I'm actually recording this, this mic, I've actually got a new mic here. It's actually a really strong mic, all right? So those guys at the back there that are having a laugh right now, it's going to pick it up very quickly. Also, when I was actually watching the video, I kind of had to watch through it again just to see that whether it is actually worth me doing this in terms of recording. There is a bit of noise in the background, and it is getting a little bit annoying if you are watching it. So just please be aware that when you're having a joke at the back there, it's actually getting recorded, and there are not just you guys watching this, but there are other students around the country watching this as well. Okay? So keep that in mind. In terms of discussing, you're more than welcome to discuss and things like that, but I'll keep you guys, when I'm speaking, if you guys just keep your noise level down, I'd really appreciate it. So today, the first question I'm going to give you guys is this right here. I want to make sure that you guys can actually see this. Okay, so what I would like you to do is, let me see, is that better resolution for you guys? Yeah, looks good. So what I'd like you guys to do is come up with the equation of that straight line right there. And as usual, I'm going to show you guys a couple of ways of doing this. So I want the equation of this particular straight line. I'm hoping that you guys have had a chance to actually do this. Now, I kept it very vague here. I didn't actually tell you guys what the context was. I didn't tell you guys what the y-axis was, what the x-axis was. I just gave you guys the question as is. All right. A couple of things to note is this. When he's talking about a straight line, you've got y equals to mx plus c. Now, one really good idea or good thing to note is this value right here, where the line cuts the y-axis. It's actually the c value, or it's also known as the y-intercept. All right, so straight away you can pick it up. You can actually see that this number here is 100. So I can rewrite this as y equals mx plus 100. Now, the next thing is trying to figure out what the gradient is. So the gradient is, man, I don't even know where to start from. I mean, you got so many different ways you can actually find the gradient. You got rise over run, you got change in y over change in x. Or if you're a fanatic like me, I actually like doing this one, which is change in y again over change in x. Just another way of writing it up. But what you want to do is choose points that you're absolutely sure about. Now the first point I'm going to choose is this, which is 0, 100. And then the second one, maybe this one here, which is 10, 600. Now I know some people get into the habit of counting the boxes to the right and then counting the boxes up to the top. While that's all right, but you got to be very careful about the units. Okay? Because some people go like this. Oh, I'm going to go from here, count up 10 boxes to the right. And if you look at it, it's about 10 boxes to the left. Up. So you don't go 10 divided by 10 as 1. That's not the right gradient. All right? So that's why I don't like doing the counting the box method. I choose the 2 points, and then I can work out the gradient. So I basically do this. This is x2 and y2, because that's the second point. And the first point is x1 and y1. Okay? So substitute these values. So you got 600, take away 100, divided by 10, take away 0. So what you end up with is 500 over 10, and your gradient is 50. Which means your equation is y equals 50x plus 100. All right, that's what I'm expecting. For those of you guys that, I know you guys are taking pictures of this, but in Google Classroom, if you go to the link, you can actually access this document live. So as I'm writing on it, it should actually pop up on your screens as well. But anyway, that's one way of doing it. If you have a graphics calculator, which is always a good thing to use to check. Remember how I taught you guys how to do the quadratic? You do the exact same thing as you did for the quadratic, except one minor change. So you go into the stat mode, you type in your 2 points, which is 0 and 100, and then your second point, which is 10 and 600. Alright, and then we press in F1, which is above this yellow button, shift, graph, and then press graph 1 again, and then right now it should look like this. Press F1 again for calc, and I guess the only difference is for a quadratic, you would press F4. But because this is a straight line, we press F2. Now in some cases, some of your guys' calculators, it'll pop up with another extra option here. It might say AX plus B or A plus BX. I would just say, just choose the AX plus B. So notice how the A, it's 50, and B is 100. That has the same format as Y equals MX plus C. Okay? So it's just another quick way to check whether you got that straight equation of a straight line real quickly. Now one more thing that I wanted to tell you guys is this. Did anybody do this for this particular graph? So I asked you guys for the equation of this graph. So how many of you guys wrote Y equals to 50x plus 100? Okay, awesome. Did you guys write anything after that? Did you guys just leave it like that? Because I want to show you guys this. When you look at this graph here, whoa. Where did it go? When you put in Y equals to 50x plus 100, it's actually going to give you the full straight line, all the way from negative infinity to positive infinity. But in the diagram, do you see the red line, how it doesn't actually go past that point? Can you guys see that? So that means this has a certain, what we call domain. This is only valid for, I said the 0, 100 existed. Sorry. That's what you're going to write it up as. That x is actually bigger than 0. Okay? Now if you're like, oh man, I hate working with these greater than or less than symbols, then I would basically do something like this. Okay, where is the point that I'm starting from? I'm starting from 0, and I'm looking at x could be anything from 0 and up. So then I would literally copy that down, 0 and x, but I always use that symbol there. That's another way of writing it as well. Okay? Now, if you're comfortable with it, don't listen to me about the green part. If you're not comfortable with it, you just got to do a bit more practice. All right? Now, there's one more thing I want to show you guys. Sometimes you get these things like, I'm going to see if I can do this again. Right here. So I can put in 0 is greater than or equal to x. Now, what you guys should see is, when we put it as that little equal sign, and if I click on the point there, that means a point actually exists at 0. Alright? But sometimes you guys will see straight lines with like a filled dot and an empty dot. So what I'm talking about is, sometimes you get a graph that'll look like this. This is like colored, but then this one has like an empty color. Have you guys ever seen a graph like that? All right. And let's say, in this case, so this x value is like, for example, 100, and this one's maybe 10. And I'll tell you what, let's actually work this out. What if this, let's put this as y and x. We're going to put this point here is going to be 100 and, no, let's try 200. And then this point here is going to be 10 and 50. So what I'm going to ask you guys is this. I want you guys to come up with the equation of this straight line. You can use a graphics calculator if you want, or if you want to use a straight line method, you could use that as well. But those are the 2 points that I've given you. Come up with the equation, and then I'm going to teach you guys how to write the right domain, particularly with the little squiggly brackets and then filling in the x and x values. So I'll give you guys a couple of minutes just to try this out. So what I was talking about was that this line, it will extend here, and it's going to cut at some point C. But we don't know what it is, and you definitely can't guess and check. But the only thing you have is the points 10, 50 and 100, 200. Alright, I'm actually quite feeling a bit lazy today, guys. I'm going to go into the graphics calculator, and I'm going to just chuck it in the graphics calculator. So, exit. My 2 points are 10, 50. So 10 and 50. And then my second points is 100, 200. So graph 1, calculate X. Now, it was really strange because when I put this question up first, I was like, oh man, I should have given these guys an easier number to work with. But that's the numbers that we've got here. So, we can write this as y equals mx plus c, 1.66x plus 33.33. Now, if you guys are really good with your fractions, and I'm going to give you guys a tip for this one. So if you have a look at, especially if you're using a graphics calculator, it's a really good tip to have. The problem is, you can't, like, see how that value of a and b, it's a recurring number, right? It just keeps going. What you can do is you can convert it into a fraction. And this is how you convert it into a fraction. You go into menu, go into the run menu, like the normal calculator, and literally do this. Just go 33.33333, I don't know how many of the 3's you can get. If you press enter, it should come up with something like this, like 33.33. But what you can do is, just above the 8, there's a little button called F to D. And if you click on that, it will convert that decimal into a fraction. So, if I go back to my equation, instead of writing it as 33.33, I'm going to write it as 100 over 3. Because that is a lot more accurate than writing 33.33. And the same thing with 1.66. You know, it was like 1 point whatever, right? 666666. And then click on F to D. That converts it to 5 over 3. So my graph now, my equation is going to be a lot more accurate than writing it as 1.66 and 33.33. So if you ever get a recurring decimal, just take down the number. If you're comfortable with converting it just in your head, then it's fine. But otherwise, go into the main run menu and then convert those into a fraction. Are we finished with this question, folks? Someone's shaking their head, they're not happy with it. What's missing in this question? Because when you draw this line in Desmos, or even just, it's going to be a full straight line from negative infinity to positive infinity. But if you look at this particular graph, I only want it between 10 and 100. Does that make sense? Because that's the only window that I'm showing you guys, right? So what you got to do is you got to rewrite this equation as 5 over 3x plus 100 over 3. So we put that squiggly brackets, and we want it between 10 and 100. Is that correct? Yeah, we got to know why no. Because of that little circle, right? I'm talking about this one right here. Because that's an empty hole, it actually means that you can't have when x equals to 100. So that means the only changes, can you guys see the change I just did? Was I too quick? Right here. Look at the difference between this symbol and this symbol here. One has equals to. So if it's equals to, then the point is going to be like colored. If it's just less than, then it's going to be empty. Is that alright? Okay.
Before you go on, under that red equation, you could also write y equals 136 and 33 and 36.
Yep.
You might prefer that as well.
Yep, that's another one. Yep, that's absolutely fine. So we could also write this as plus 33 1/3. That's another way of writing it as well, if you're comfortable with it. Okay? It's just with decimals, guys, especially with recurring decimals, you want to make sure that the fractions are actually a lot more accurate compared to recurring decimals. Because, like, if you go 33.34, it's not the same thing as saying as 100 over 3. So just keep that in mind. Just being a little bit picky about it. Okay, so let's go back to this gradient here. Okay, I mean this diagram. I'm going to tell you guys a little bit of a story. And this is a true story that happened to me in 2013. And the story is this. Wait, I need to get my graph here. So you might be wondering why I chose this particular one. All right? Because I actually went and talked to what is it? In 2013, this is the story, all right? And you got to listen to the story because it will make sense of how we're going to draw this graph. In 2013, I came back from my trip and I had all of our stuff was in storage, all right? So we needed to move all of our storage stuff from storage and into our new place that we were renting. So I rang up a couple of moving companies, and the first guy, believe it or not, he actually said, I'm very particular on time. I actually charge $100. And then after that, I charge, my initial charge is $100, and then I charge literally by the minute, or like by the second almost. He was that accurate. He said, but I charge $50 an hour. So remember that first graph we did? The first graph we did, this is what his thing actually looked like, because he charged $50 an hour, and then that initial $100 cost. All right? So we're going to change up a few things. We're going to get rid of y. We're going to replace it with cost. We're going to get rid of x. And we're going to replace it with t, h, whatever you want to put it as. I'm going to put it as t, measured in time, measured in hours. All right? Did I actually tell you guys this story before? Okay, no. Now, I called up a second company. Now, the second company said to me, for the first hour, we're going to charge you, I think it was $50. No, actually it wasn't $50. Yeah, it was $100 actually. They also said, first hour, we're going to charge you $100. But after that, every half an hour, they're going to charge me $25. Is it? And I'll give you guys, this is what he actually said. He basically said, so this is company number 2. He said, he's going to charge me half an hour for and $100 for the first hour, and after that, it's $25 per half hour. But here's the thing, though. He worked in half an hour intervals. So, for example, if he worked an hour and 15 minutes, he charged me $125. If he worked an hour and 29 minutes, $125. But if he worked an hour and 31 minutes, he was going to charge me $150. So his thing was $25 for every half an hour. So he doesn't actually work in, like the other guy was pretty cool. He was like, I'll work like to the minute in seconds. But this guy was like, nah. So if I go to like an hour, and I said to him like, so hang on a minute. So if you work an hour and 29 minutes, you're going to charge me $125. But if you work an hour and 31 minutes, you're going to charge me $150. He's like, yep, that's my rule. Now, how are we going to put that in a graph? So remember, 1 hour and 29 minutes is $125. But 1 hour and 31 minutes was going to be $150. So I asked him this question. What happens at an hour and 30? What do you think he's going to charge me at an hour and 30? Is it going to be 125 or 150? Well, what would you be happy with if he worked for an hour and 30 minutes? Would you be happy paying 150 or 125? Probably 125, and that's what we came to the conclusion. So, how are we going to draw this as a graph? And what I would like you guys to do is just have a look at this. I'll do the first one. Alright? So for the first hour, he was going to, you know what, I'm actually going to get a different graph, guys, so I can actually get a bit more room to work in this. Just give me 1 second. Same graph, but I just needed a little bit more room to actually show you how this would actually works in. So, what we got is we got $100 for the first hour, right? So that's going to be a flat line like this. Does that make sense? Because 1 hour. Doesn't matter if he works half an hour, 45 minutes, 1 hour. He's going to charge me $100. Now the second one, he's going to charge me $125. Does that make sense? Yeah? Okay. And then 150. Oh, have I got a little bit? No, I need a bit more. Does that make sense? 150 for between 1.5 hours and 2 hours. Is that correct? You got a couple of people shaking their heads. Why is that? It's yellow. Yeah, you need the circles, right? You need those little circles, because what happens is, this graph right now, if I go to 1.5 hours, it's actually got 2 filled in dots. So we need to change one of them. One of them to be empty. Which one are we going to change as the empty one? The top one or the bottom one? Which one? The top one. We're going to change the top one because remember, at 1.5 hours, we are trying to pay the cheapest value. So that's going to be an empty one. That's going to be that. What about 1 hour? Do we need to do something for 1 hour? What do we need to do? Which one has got to be the empty circle and which one's got to be the filled circle? Top one again. Top one's got to be empty because at 1 hour, we don't want to be paying $125. We want to be paying $100. So that's going to be colored in. So what ends up happening is you've got a series. Need to get that right. Oops, sorry. Does that make sense? Okay. How do we write the equations for this? That's the challenge I'm going to give you guys. I'm going to give you guys just 2 minutes. I'm going to pause this. There's a reason why I gave you guys this. I think this is quite, it's not challenging. It's just, trust me. I'll show it to you and see if it actually makes sense to you. Now, how many of you guys took these points here, put that in the graphics calculator and try to get an equation? I hope you did not do that because that's not going to work. Because first of all, look at this. Is the green ones, the series of them, is that actually one straight line? No. You can only use the graphics calculator with that mode if it's one straight line. But however, in this green ones, you've actually got 1, 2, 3, 4, 5, up to 5 right now that you can see. Right? You've actually got 5 straight lines. So you need to actually do it 5 times, but from here to here and so on. But no, that's just too much work. Here's how you do it. Whenever you get a flat line, so this is the green company here. C is equal to 100. Now, what was the time limit for the 100? Was it from 0 to 1 hour? Now here's the question. Do we put this as equals or greater than? Yeah, because we don't want to put equals, because otherwise we're going to pay him $100 for doing absolutely nothing. All right, so you don't want to put an equals there. We're going to put 0 to 1. But at 1 hour, is that included in the $100? So, so that means we'd put that. What about 1 hour and 1.5? How much is it at that time? Can't you say that? Because it's one flat line, right? So we can actually write it as 125. And then 150 from 1.5 to 2. Now there's a reason why I haven't put those symbols. If it's included, then we would put that as less than or equal to. If it's not included, then we just leave it as less than or greater than or whichever it is. So you only put the equal sign if it's included or if it's like an empty white circle. Okay, and of course this just keeps going on because you could actually have it like 175, 200 and so on. Okay, next thing I want to do is this. Let me just see. Let's say this is number of ice cream sold versus what can we do? So redoing that question, we've got $25 per bucket of paint. Okay? What I'd like you guys, just a rough sketch, what would this diagram actually look like? If it's $25 per bucket of paint, if you were to draw that, so say this was cost, this was number of buckets of paint. Can you guys just give me a rough sketch in your books of what this graph would actually look like? Okay, so here's my rough sketch. But before I do that, I'm going to create a little table here. So that's going to be my buckets, and that's going to be my cost. So if I have 0 buckets, $0, 1, it's 25, 2, it's 50, 3, it's 75, and so on. So, roughly putting this, I did ask you guys to just sketch it. So that's 25, 50, 75. So if I look at my 3 points, just roughly, right now, it's there. So with this one, that's what the equation looks like. The graph looks like. Am I correct? You can see shakes going both ways. And this is what we mean by discrete data. Discrete means it's countable. Now, by joining the lines, you're actually saying that you could potentially buy 1.5 buckets of paint. All right. Remember that when you go to Bunnings and say to them, like, I want to buy 1.5 buckets of paint, they're going to be like, no, you're going to buy 2. All right. There is no 1.5. And you can't actually buy 1.99 buckets of paint. So in this case, it's really important that the graph is actually not joined up. All right. It is just a bunch of points put together, and that's what discrete data is. You can't have numbers in the middle. It's like countable. It's counting data. All right. Last but not least. Okay, I'm going to give you guys this question here. This one here, what I've got is, I've got a straight line right here. I want you to come up with the equation of that straight line first. So that's the black one. Then I would like you to come up with the equation of the red line. All right, and then the final question I'm going to ask you is this. 2 questions actually. Find out what this point is. And then the third thing is I want you to move this red line so that it actually goes through this point here. So those are the 3 things that I'm going to ask you to do to finish up. We only got about 5 minutes, guys. I'm going to try and finish this question, but I'll give you guys about 3 to 4 minutes on this. So I want you to move the red line to where the green line is. So just to go back on the question, I don't want you guys to work out the red line or the black line. I don't want you guys to work out where it meets. What I would like you to do is move the red line to the green line. That's what I want you guys to do. So the red line and the green line has the same gradient. That's my clue to you guys. That's my hint. So I did ask you guys to move the red line to the green line. Now, that means the red line and the green line has the same slope. I can work out the slope of the red line by doing this. Gradient is change in y over change in x. So we got x1, y1, x2, y2. So gradient equals 20 take away 200 divided by 40 take away 10, which is negative 180 over 30, which equals negative 6. Are we okay with that? So that was step number 1, is finding the slope. Now, if the red slope is negative 6, then the green slope is also negative 6. But I want you to come up with the equation of the line. And watch this, folks. This is like really useful little trick to have. You know that the equation of the line is y equals mx plus c. What we know is the gradient is minus 6. And it also goes through the point 50, 100. So you can actually write this up. 100 equals minus 6 times 50 plus c. So you got 100 equals minus 300 plus c. And c is 100 plus 300, which is 400. So the green line's equation is minus 6x. Is that right or what? Is that okay? Yeah, that's literally how you do that, folks. Just use this little trick here. Find the gradient, 1 point, then you can just write y equals mx plus c and substitute it. Now, let's say, I want to show you this last bit here. You are struggling to do this part here. Let's say you're like not happy doing that part. Then go into the graphics calculator. You click on menu. Go into equation. And watch, this is the ultimate one that I'm going to show you guys. Alright, trust me, this will make so much more fun. There's a thing called solver. You click on that. And see how it says equation? You literally got to type it in. So you got to go alpha. Where is y? Y. And then shift equals alpha m. Where the hell is m? There. Times alpha x plus alpha c. Where is c? There. So keep watching. You substitute y as 100. M is minus 6. X is 50. And then you go to C. Right now you're trying to figure out C. Press solve. And it does it for you, which is 400. Okay? As I said, ultimate one. Guys, that's us for today. As usual, I'll upload the video shortly and send you the links. Thank you.